Hi everyone, let's discuss hybridization, which is explained for polyatomic molecule. Polyatomic molecules means the molecule which contains more than two atoms. So I am writing some cases here. You can see that these molecules contain more than two atoms. So hybridization has been explained for all these atoms. And these all are polyatomic molecules containing 3, 4, 5, and 6, 7 atoms respectively. Will also discuss why BeCl₂, H2O both are triatomic molecule, but BeCl₂ is linear and H2O is bend shape. BF3 and NF3 both are tetraatomic molecule, but BF3 is planar and NF3 is pyramidal. Right, so these queries have been solved by hybridization. What is hybridization? Let's understand. For example, carbon has 6 electrons, 4 are present in the valence shell, and in valence shell you can see that 2 electrons are 2 electrons are present in 2s and 2 are present in 2p, which makes a total of 4. It needs 4 more electrons to complete its octet. But since we have 2 unpaired electrons only, it can form only 2 bonds. So how will it form 4 bonds? If one electron from 2s orbital jumps to the remaining or the empty 2p orbital, then it can form 4 bonds. And this is what actually hybridization does, that it unpair the electrons to make required number of bonds. Let's take a wonderful case to understand hybridization. Suppose I take 1 glass of roux afza and 3 glasses of milk, and I mix all these 4 glasses together, and then I pour the mixture again into the 4 glasses. So I will find that each glass contains 25% of roux afza and 75% of milk. So each glass will have 75% milk and 25% roux afza. In the same way, when atomic orbitals hybridize together, then the hybrid orbital will have similar percentage of the mixed orbital to in which in the ratio they have been mixed. So atomic orbitals of approximately equal or exactly equal energy hybridize together to form hybrid orbitals. The number of hybrid orbitals formed are equal to the number of atomic orbitals hybridized. Hybridization is a hypothetical phenomena, and number of atomic orbitals will be equal to number of hybrid orbitals. So we can also say that here orbitals are conserved. These hybrid orbitals follow Pauli's exclusion and Hund's rule. It means that each orbital can have 2 electrons, and both the electrons will have opposite spin. Here, since we are only discussing the case of unpaired electrons, so both the one electron will be from one atom and another will be from other atom. So half filled and completely filled orbitals participate in hybridization, but in this video I am not discussing the case of completely filled orbitals as of now. So Pauli's exclusion and Hund's rule we have already studied in chapter atomic structure. Let's discuss types of hybridization. In this we'll have first hybridization, which is sp hybridization. Let's take a case of beryllium chloride. Beryllium has 2 electrons in the valence shell, and both of these electrons are paired and present in 2s. So in ground state it has 2s2 configuration, so one electron will jump into 2p, so that now we have 2 unpaired electron, and beryllium can form 2 bonds with one chlorine with 2 chlorine atoms. So 2sp hybrid orbital will lie at an angle of 180 degree, and thereby the molecule is linear in shape. This smaller lobe represent 50% S character and bigger lobe represent 50% P character. And now we can see that why BeCl₂ is linear in shape. Next case is sp2 hybridization, and example is BF3. Boron has again 3 electrons in the valence shell. 2 are paired, 1 is unpaired, so we have to split. We need 3 unpaired electrons, so 1 electron from 2s will jump to 1 electron in empty 2p orbital. So thereby we have now 3 unpaired electrons in the excited state, and these 3 unpaired electron or unpaired orbitals will hybridize together and will form sp2 hybridization. These 3 hybrid orbitals will lie at an angle of 120 degree with each other, thereby the molecule will be planar. The shape is trigonal planar. So BF3 is a trigonal planar molecule. Another case is sp3 hybridization. Here I take the case of methane molecule. Carbon again has 4 valence electrons. 2 are paired and 2 are unpaired. So in order to make 4 bonds, carbon needs to excite 1 electron from the paired electron. So one electron will go to the 3p empty 3p orbital, and we'll now have 4 hybrid orbitals, and each of the hybrid orbital contains 1 unpaired electron. These 4 orbitals will lie at an angle of 109 degree 28 minutes to each other, and thereby giving a tetrahedral shape. Tetrahedral means 2 of the valencies will be in one plane and 1 will be out of the plane and 1 will be below the plane, and all the 4 valencies are equivalent. Next is sp³d. We take the case of PCl₅. Here phosphorus has 5 electrons in valence shell, and they are present in 3s and 3p orbital. Again in 3s both the electrons are paired. In 3p we have 3 unpaired, but to make 5 bonds we need 5 unpaired electron. So 1 electron from 3s will jump into the next available empty orbital, which is 3d. So now we have 5 unpaired electrons present in 3s, 3p and 3d orbitals. So all these 5 orbitals will hybridize together and will form 5 new hybrid orbitals. 3 of them will lie at an angle of 120 degree to each other and are known as equatorial positions, and rest 2 will occupy the axial positions, which are at 90 degree. So these 3 will form a plane and trigonal planar, whereas these 2 are above and below the plane, so thereby giving molecule a shape of trigonal bipyramidal. Bipyramidal means 2 pyramids are present. You can imagine that 2 pyramids are present here, and their bases are touching each other. So that is how we get. Now the axial bonds are longer here because they are getting repelled by 3 equatorial bonds. So therefore 3 equatorial bonds are smaller and 2 axial bonds are longer. That is why when PCl₅ molecule is heated, 2 axial bonds are broken and it forms PCl3 and Cl2. Next is the case of sp³d². Here we take the case of sulfur. Sulfur has 6 electrons. Again 4 electrons are paired. It means that here we need 2 excited states because we need to have 6 unpaired electrons. So these 2 electrons will go to 3d orbitals, and we get 6 unpaired electrons present in the s, p and d respectively, as shown here. So in here we need 2 excited state because we will excite electron one by one first from 3p and then from 3s. So now these 6 valencies we have to arrange. So these 6 orbitals will, first 4 will lie in a plane at 90 degree to each other, and 2 will be above and below the plane. So thereby this molecule will be having octahedral shape. Octa means 8 and hedral means faces. You can see that 4 valencies are in one plane and one is above and one is below the plane. So octa means Octa means 8 faces. You can see that 4 faces are above the plane and 4 faces are below the plane. Now here equatorial and axial bonds, equatorial and axial bonds are similar. Why? Because bond angle is same, so you can consider any of the 4 valency in one plane and it will become equatorial and remaining will become axial. So that is why there is no shorter or longer bonds in case of SF6 or in case of sp³d² hybridization. Alright, so in the next video I'll be discussing lone pair. Thank you so much.